Okay, so for the first problem, I chose yellow problem number 1. The chemical formula is C4H8O2. Let me just make this a little thicker. Okay, so I already calculated the degrees of unsaturation. The degrees of unsaturation is 1. So moving on to the IR spectroscopy, I'm going to be honest, this confused me, but I did notice this carbon double bonded oxygen stretch, so I made note of that. As for the CNMR, this right here, the 180 ppm, this peak right here is most likely a carboxylic acid because it is at 180 parts per million. These over here, these guys over here, these are most likely just CH2s and CH3s. I'm just going to do a slash. So yeah, so now moving on to the HNMR. This is where I got most of my information. So just starting this off, there is no symmetry in this. All of these peaks represent the hydrogens. Like it's not reduced. There's no symmetry, and there's no symmetry. Okay, so moving on to this, this is going to be an OH of some sort because it has the BS, and the only molecule that's not carbon or hydrogen is oxygen. So it's going to be an OH of some sort, and it is a singlet. So it's most likely going to be kind of off to the side by itself, attached to a carbon that is attached to other molecules that are not hydrogen. It has no neighbors. Moving on, we have a CH2 that is a triplet, so it's going to have 2 neighbors. Another CH2 that has 2 neighbors. Oh no, it's a multiplet, so it's going to have multiple neighbors. And then we have a CH3 that is a triplet, so it's going to have 2 neighbors. So now automatically I can kind of tell, since this is a multiplet, it's going to be in a chain. Since this is a multiplet, it's probably going to be in the center. This one's going to be in the center. This one's going to be at the end. It's going to be attached to this guy right here. And then this guy that is a triplet, we're going to see where he fits in. Hello, Miss McMahon. Just kidding. Okay, so I'm using my like a camera for my computer because my phone camera is broken. So now that we've had that established information, I'm just going to start off with the carboxylic acid. So it's going to be bonded to an OH, and then we have a double bond oxygen. Also, this double bond is going to take care of our degrees of unsaturation of 1. All right, so now we should bond that to another carbon. This is going to be the CH2, and it's going to be bonded to another carbon, another CH2, and then finally it's going to be bonded to a CH3. And this is going to be, this one right here, this guy is going to be the CH2 that is a triplet because it has 2 neighbors, these 2 hydrogens. This one is going to be the CH2 that is a multiplet because it has 1, 2, 3, 4, 5 neighbors. And this guy over here is the CH3 that is a singlet because it just has, that is a triplet because it has 2 neighbors, these 2 guys. So yeah, that's the first. This is yellow problem number 1. Okay, so now on to the next problem. So I'm doing green problem number 2 for the next one. Okay, so for this right here, this curve is very indicative of an alcohol. And then this one, I was just like, it might be a CH, I'm not sure, but this is definitely an alcohol. I don't know what's going on over here. I'm not paying attention to this. I don't like it. Okay, so now moving on to this. Oh, wait, I need to calculate the degrees of unsaturation. Let me do that real quick. Okay, so 3 times 2 is 6 plus 2 is 8 minus 8 is 0. Okay, so the degrees of unsaturation is actually 0, so that makes sense. Okay. Alright, so moving on to the CNMR. So this is gonna be a carbon bonded to an oxygen, and then these are just gonna be most likely CH2s or CH3s. So that's what I got from the carbon NMR. There's no symmetry. All the carbons here, there's 3 peaks, there's 3 carbons. I don't have to worry about anything else. Now for HNMR, my favorite. I love HNMR. Okay, so right here we have, oh, okay, so actually, yeah, so there's no symmetry. It's not reduced. Everything that's seen here is going to be represented up here. So it's nice, easy, and simple. So down here for this first peak, we have a CH2. It's a triplet, so it's going to have two neighbors. Down here, we have the BS, and it is a singlet. Well, that's what the S stands for in BS. And it's just one hydrogen, so this is going to be our OH, and there's only one oxygen, so yeah, it's OH. And it has no neighbors. It's lonely. Okay, so for the second peak, it's going to be a CH2. It's a multiplet. It's going to have a lot of neighbors. It has a lot of friends. Something the OH does not have. It's lonely. So now moving on to the, oh, I forgot to underline. Okay, so now moving on to this one. This is a CH3. It's a triplet, so it's going to have two neighbors. But yeah, this is a CH3. Okay, now moving on to the paper. Alright, so I'm going to start off with the OH. And then attach that to a carbon. It's going to have two hydrogens, and this is going to be this one of the CH2s, right? And then we have to attach it to another carbon that is also a CH2. So now we have one CH2 that is a singlet. So yeah, because it only has two neighbors. So wait, no, it's a triplet. Oh my god, why do I keep getting this mixed up? Okay, so it's the carbon is a triplet. It has two neighbors. All right. Now we move on to the next carbon. This is going to be the CH3. Yeah, and this all works out because this CH2 right here, this is the CH2 that is a multiplet. It has 1, 2, 3, 4 neighbors. Wow, so many friends. This one over here, this carbon over here is the CH3, and it is a triplet. It has two friends. So this all works out, and then we have the OH up here. This hydrogen's lonely, and this is the CH2 that is a triplet, but I already talked about it. Anyways, yes.